Welcome to qnawire.
Would be a diagram of the system, and we can then say that the precessional angular velocity would be given by equation 1113c. And so the precessional angular velocity would be equal to mgr over the moment of inertia times the angular velocity. This would be equaling mgr divided by the mass times the radius of the wheel squared times omega, the angular velocity. Of course, the masses then cancel out, and we have simply g times r divided by the radius of the wheel squared times omega. And so the precessional angular velocity would be equaling, we can say 9.80 meters per second squared multiplied by 0.20 meters. This would be divided by 0.325 meters quantity squared multiplied by 4.0 pi radians per second. This is equaling 1.477 radians per second, and we can then say that the precessional angular velocity is equaling 1.477 radians per second, and then we're going to convert to RPMs. So 1 revolution for every 2 pi radians. And then we're going to multiply this by 60 seconds for every minute. And the precessional angular velocity is equaling approximately 14 revolutions per minute. Now here, we see that in the figure here, the torque from gravity is directed back into the paper. And this gives the direction of the precession. So when viewed from above, we can say that the wheel will precess counterclockwise. So this would be our direction, and this would be our magnitude. That is the end of the solution. Thank you for watching.